So what is Aerospike? As Ido said, when I founded the company, I believed that the operational database was underinvested in. And the idea of building a true order 1 distributed hash table that was incredibly efficient and worked with flash memory with specific optimizations for flash could be something that a lot of people could use and a lot of people needed. So we built it. And I'll go through just a little bit of the technology, but what I found over time is that this architecture is still a bit of a mystery to a lot of people. Why do you need 2 separate systems? Why do you need a big back-end analytics system and then a separate front-end system to actually do your work moment by moment at internet scale? The answer, as it turns out, is can be shown in the bottom of this. This is from one of our payment processor fraud gateways. Let's say you only have 500 payments that you're trying to settle every second. That sounds like a small data problem, right? 500 per second. Compared to what we've already heard in some of these talks, that's nothing. Well, what if you want to touch 5,000 data points for each one of those calculations, and they're very dispersed? They're not similar, they're not different, they could be your machine learning features, they could be just about anything. Well, you might need to do then 5,000 individual lookups to get enough data to drive your decision. That's the kind of architecture that I see frequently, and the key to it is a separation of compute, those are your decision engines, and a storage engine that is capable of these kinds of throughputs. There's often a question even in containerization. I'm supposed to speak in London at QCon tomorrow about containerization of data. And what I tell people is you really should think about your data architectures on the front edge with a one-hop architecture. You need to have your compute that is stateless. You need to have one hop to your data. Now, if you have a separate storage class behind it where you're actually doing another hop out to a virtualized storage environment, you're going to have problems. If you have a cache inside that compute engine, you're also going to have problems. Those are the problems born of consistency. Now, some of you, you have many choices in databases. We know that at Aerospike. These are some of the numbers we've had recently regarding Cassandra. It's not that Cassandra is the fastest database out there, but it is one that you're all familiar with. So if you do see a system like Aerospike running on the same SSDs, this isn't just about getting SSD performance, it's about how to optimize for SSDs. So Cassandra on SSDs versus Aerospike on SSDs. But we're really proud of this kind of graph. So that's showing your difference in throughput, and you see the difference in throughput changes very, very little. How did we do it? Well, we did it by looking at a different clustered architecture. Remember the earlier talk who was talking about Zookeeper? I'm sure a lot of you use Zookeeper to do cluster coordination. We built a peer-to-peer system, so there is no master node, there is no Zookeeper node. Instead, they coordinate amongst each other in order to do their clustering based on our own version of Paxos. So it's a system that is very peer-to-peer, and it's also built with a very, very high-quality hash function, one called RIPEMD160, which is the same hash function used in Bitcoin. It's a hash function with no known collisions. That's a huge benefit when building a system of this sort. So it automatically balances the data in a very clean way. But what could you actually use a system like this that's capable of 1 million transactions per second per server using flash? So it has all of the benefits of in-memory in terms of performance, latency, sub-millisecond latency, but with the economics of flash. These are a small set of our customers currently. You'll notice a few names on there you might recognize. And of course Nielsen, right there in the middle of the ad tech companies. We're going to talk through a couple of those. So last year, the guys at Nielsen talked about using Aerospike for machine learning. I thought I'd run through that case first. So it's a fairly standard system within Nielsen's machine learning, but what's interesting is it's online. And if you attend any talks by Google about TensorFlow, they're real believers, as Nielsen is here, in online machine learning. The idea is that if with online machine learning you build one data pipeline, instead of having to build multiple data pipelines, instead of having to build a back-end system and then import the data forward into real time, instead use microbatches. And Brent, actually no, some of the guys are here today who I stole from their talk about that, about using Aerospike for it. Now, what I did not appreciate until I talked to them was not only could you use Aerospike to store that user data chain, which is necessary for things like machine learning, or behavior per IP address, as one of the other guys I talked to earlier today does, it's also interesting to use as your online model store. Think about the machine learning problem where you're going to recompute models in micro batches every few seconds, like they do at Nielsen. Well, in that case, when you elect a particular node to do the recompute of your model, you then need to flush that model out to all of the other compute engines that are relying on that model. Because we all know now with multi-layer machine learning, it's all about having a lot of models and having the relationships of those models so that you're not spending an hour or 2 hours in your recompute time. So it turns out you need a system with the kind of speed of Aerospike. Now, it's not as big, as you see in this slide, as their user data component, but it's still a lot of models. And the ability to have lots of models, one per audience, is something that they really like about their system. So another company in mobile advertising is called Immobi. They're, I think, #2 in the world in mobile, and they use Aerospike. Recently, they use the same kind of architecture, where they have a back-end system and a front-end system. They recently switched over from having only 4 terabytes on the edge to actually now having 40 terabytes on the edge. They thought that kind of scale was necessary to use something like HBASE, but they found out with Aerospike, with those new SSDs that I talked about last year, you can now put in 2 terabyte, 4 terabyte SSDs, put a whole bunch of them per server. It's very practical these days to do things like 40 terabytes on the edge. Let's talk for a moment about a completely different non-advertising use case, because I think this is this is pretty interesting. So one of the large brokerage houses in California, a US brokerage house called Charles Schwab, uses Aerospike, and they use it for the current trades that are being settled. In the American financial processing system, settling trades has become more complicated in the last 10 years, since 2008. What they now have is, instead of just having a few small large public exchanges like the New York Stock Exchange or the NASDAQ, they now have a large number of private exchanges, 40 or 50 different private exchanges. So if you're going to settle one trade, you have to break it up into what's called child trades, and each one of those has to settle separately. There's a number of different analytics that need to be done now, which is finding the efficiency of every single one of those markets in parallel so that you know how to most efficiently break up the next trade. Something I didn't realize. But once you started changing that one database transaction for one trade into, well, now I have to do 30 or 40 lookups, I have to look at per stock ticker symbol trade efficiency, you've now got a much larger database problem than they ever had before. Since it is trades in flight, they also use other applications, for example, their risk application. We all know from 2008 that risk is more important than ever in financial services. So being able to look at trades that have not yet settled is actually where all your risk is. Their previous system was a streaming system with no shared database. So they could not actually know what trades were in flight. By putting a database in the middle, they were suddenly able to solve those problems. Some of the largest users of Aerospike right now are doing fraud prevention. You heard about fraud prevention in one of the earlier talks. But what I'm finding is that those guys are actually building things like 500 terabyte Aerospike clusters. These are the large payment guys. So people like PayPal use Aerospike for this use case, and they switched out of using SQL. So what happened previous to this, this change in perspective with fraud detection, previously they had rules engines. There's a few well-known ones. One's called Pegasystems, and what they would do is they'd have a big back-end analytics systems that would once a month or once a week calculate a new set of rules. There's all sorts of rules. If I usually make transactions of this size and then it's of this size, if I usually am in this geographical region and now I'm in that geographical region, those are some simple rules. And their rules engines would run through those and detect some fraud scores. What they want to do now is use the algorithms that we all know and love from advertising to do real prediction on the data sets they have. People like PayPal have a huge amount of data. They have data about every single IP address, every single market basket, everything that flows through. But what was exciting about working with PayPal was when the companies eBay and PayPal split. At PayPal, they had a new directive. We are going to become the payment company for the internet. And they were told, you have to plan for 10x growth. You have to become more agile in the systems that you use. You have to be able to scale. So these guys didn't start with 500 terabytes. They started with a modest 30-node cluster. They've ended up with a system this big. And they're able to now do things they weren't able to do before. Another interesting case for Aerospike is a little more mundane, but we're finding that within the world of travel, there's a lot of caches. And even though we consider ourselves a database company, caching is still pretty important. Having a cache that's persistent, that doesn't take a lot of warm-up time, because it's using persistent storage, can be a pretty big deal. So I'm going to keep it brief. Thank you for your time. I have to run off to London. I apologize. But back at our booth over there's this guy, Ronan. He's based in the US, but he is Israeli by birth and by inclination. So if you have any further thoughts about Aerospike, you want to know about the technology, how we do our clustering, how we do our storage, go look for that guy. And we also have an Israeli-based distributor named Brillix. There's a few of those people here. So like I said, we really love and appreciate the Israeli market. And therefore, we've sunk a lot of our investment into making sure that this market is successful for us. So thank you very much.